Hey, how's your day going? I hate COVID. Okay, so moving forward, hey, good job, Mateo. Interaction, it's a thing. I think that I wanted to mention, well, today is Wednesday, and the last content that be related to the exam, and the exam is like tomorrow, it'll open at 5 o'clock. You could take it anytime between tomorrow at 5 p.m. and then midnight on Friday night. We're turning it in by 11:59. Sample exam questions and answers online. You could ask a lot of questions about those sample exam problems tomorrow in class. Also, from anything that we've done so far that you think would be helpful for you for the exam, ask about that tomorrow in class. That's all good. And the chapter 8 and 9 content probably won't take all that long today at all because we've done it all before. But I want to sort of walk my way through an example relatively start to finish in terms of emphasizing the residual analyses in a way that we could spot whether there is a difference across some groups or not, and whether maybe one of the relationships should have been linear, should not have been linear, but we fit it as a straight line, that sort of stuff. Okay, so Hal, how about I'll sort of start by mentioning something, sharing a screen, and then we could go towards any questions that you might have on administrative issues before we move forward with content at all. Okay, so over here, I've got for the week, here's what to do. And then our homework that's assigned today, the chapter 8 and 9 problems. Yes, it's due by Monday, but if you do it between now and tomorrow's class session, it's a good opportunity to ask questions about these homework problems and finish them up before the test hits. Also, homework 4, I guess you're going to do that and get that done by tonight. And then we're having a lab today on residual checking. Okay. Any administrative questions at all before we move towards content? Okay. So let's move on towards content questions. And as always, please feel free to just interrupt me during the part of the class where I just talk, because if you got a question, then is the time to ask. Okay, so in terms of chapters 8 and 9, it really does boil down to the assumptions we made earlier when we talked about regression. And the assumptions we made earlier when talking about analysis of variance, those are still assumptions that we want to or need to make to feel comfortable using that general linear model. So let me remind you of the assumptions. Independence. The way I'd phrase it this way is, if I tell you that for one individual, and let's go with the San Luis Obispo homes, because you recently were dealing with that one. If I tell you one home is priced at $75,000 more than you would have expected based on the size of the home, the size of the lot that it sat in, and the neighborhood, and even appropriate interactions. If I told you that one of the homes was priced $75,000 higher, that doesn't help you predict any of the other individual homes' values. Okay, knowing that one error wouldn't help you predict any of the other errors at all. The way I phrased it earlier this term is, if I tell you the height of my neighbor across the street, and you think, oh, well, and his weight, if you think, oh, he was very light compared to what you would have predicted for someone as short as he is, Okay. Knowing that he has a negative residual doesn't help you at all predict my weights, variability from my predicted weight based on my height. Knowing a bit of information about some of the X's doesn't help you, or X's and Y's doesn't help you with the others at all. Okay. Second, okay, and maybe just first, and what is specifically covered in one of our chapters here, 8 and 9, is, hold on, maybe there's groups that are sort of natural that could be lumped together. And you started looking at that in the lab, like, oh, systematically, these groups are higher or those groups are lower. That would be a lack of independence. Homogeneity of variance, sometimes it's called homoscedasticity by economists. Equal spread of the residuals is what we're going to be looking for. And that's fair to say, equal spread of the residuals regardless of the values of the explanatory variables. So whether your X's are low or medium or high, and whatever the combination of all the X's are, the same vertical variability in your Y variable around what you would have predicted. I guess normality, yet another thing, and that's normality. We got that one. That's usually easy to check for. Linearity, meaning a curve wouldn't have been better. A curve would not have been better. And I would say additivity, that's a way of saying, well, we should check for whether there is a need for an interaction. And if there isn't a need for an interaction, you say the model's additivity or has additive, but sometimes we can spot in residual analyses a problem of a lack of additivity that we could fix by just adding in an interaction term. Okay, essentially linearity, additivity, our model wasn't perfect. We needed to tweak it. Okay, so maybe let's look at an example all the way through, and I don't want to deal with that one. Nope, don't want to deal with that. Let's just go with an example. And because we're dealing with the slow home sales, again, you've got a bunch of data here, and now we know how to deal with zone as a categorical variable. So maybe I don't need all those dummies for which zone is A, B, C, D, E. I call it, well, A, B, C, D, E in one context, as zone 1, 2, 3, 4, 6 in a different one. Maybe I'll just delete those. We could go with what zone it is, and zone is categorical in nature. The year that the home was built, the square footage of the home, the day of year of the sales, these are characteristics that mostly are indicators. Fireplace total, 0, 1, or 2, a lot of zeros. Is there a dining room? Is there a living room? I'm going to say let's ignore and okay, smallify, because okay, it's hard to make it smaller. Okay, good. Number of bedrooms, number of bathrooms, etc. Okay. So let's try our model, and I'm going to go ahead and fit a model that seems, in my mind, plausible at first. Sales price should depend on, well, the size of the lot on which the home sits, the size of the home in square footage, what zone it's in, and well, let's maybe also have, I think maybe the number of bedrooms should count as well. We didn't put bedroom in our analysis earlier. Actually, I want to delete zone for now to make a point. Okay. So size, square footage, bedroom count, and let's even go with the age of the home. Not really the age, but the year in which the home was built. So this is not a model exactly that we fit before, but it seems plausible that we could do that as our first cut at an analysis. We'll look at the residuals and see if there are any issues here. Now, the actual by predicteds, I find hard to utilize, but basically you're thinking this should be a trend. I find it easier to look at the residual plotted against the predicteds. And here, equal spread almost. Maybe there's something a little bit goofy, which a little bit wider here than down here. For predicted cheap homes, there's much less variability than if I expected the home to be quite expensive. It could be a lot less expensive or a lot more than I had thought. Let's look for our first thing first by assessing the interaction. I'm just making nonsense. Let's look for first things first by seeing if there's a difference across the zones. Okay. So to do that, I'm going to go ahead and save our residuals. So save columns, the residuals. And these new residual sales, that's how far off the sales price is from what I would have predicted based on my model. And I'm going to go ahead and graph that Y variable, and maybe I'll use Graph Builder for this purpose. I'll have the residual of the sales price on Y-axis, and I'm going to have X variables individually one at a time along the X-axis, and maybe the year that the home was built. You tell me, do you see a trend here? I think there's about the same amount of vertical variability, whether it's a home that was built in 1940, there weren't too many of those in our data set, or 1960, or 1980, or 2000. It looks like about the same vertical variability. So far, so good. One thing we can do as a way of using a hack to tackle the question of whether there is equal spread or not is I can create a new column that would be the absolute value of those residuals. So I'm going to call ABS for the resid. And under column properties, I'm going to fit I have a formula there, which, well, the formula I want to go with is numeric, the absolute value of the residuals down here. So where we had 6,044 negative, meaning the home was $6,044 less than I would have predicted. The absolute value of that is just 6,044. I just dropped the sign if it was a negative sign. If I were to show you a graph of these absolute value of the residuals along the Y-axis, and the variable in question, a year built, along the X-axis, that wiggly line, let's make it really straight. We could do that with our friend Lambda, slide it to the right, pretty darn straight. And that is telling us this is pretty flat, yeah? So it says whether we're very early to medium, late, or very late in our data set in terms of the year that the home was built, the vertical variability is about the same. The absolute value of the residual is what I've got on my Y-axis, and it's not trending upwards or downwards dramatically across the year that the home was built. Okay. Y'all good with that as a quick hack for looking for a lack of equality of spread? If I saw a steep line trending upwards or a steep line trending downwards, I would say that's evidence of the lack of equality of spread. That's not something I see here. Maybe to check for equality of spread that would be different in the different ranges. Yeah, I don't know. For lambdas that are reasonable, like not really wiggly, for lambdas that are reasonable, and this looks still reasonable to me, we don't see it dramatically different. The typical absolute value of the residual is always $3,000 to $5,000, always about the same. Okay. I could graph the residuals. Again, a graph builder could be used. Maybe let's grab those residuals and residual sales price plotted against. Well, how about what variables did we put in our analysis? We had the size of the home. Again, maybe the wiggliness is too wiggly. Let's make it less so. I'm seeing here what looks like no curvature Okay, and what I'm seeing here doesn't look like I have more variability earlier than I do later. But we can again check that by, instead of using our residuals, maybe just the absolute value of those residuals. That's going to be a way to check for curvature, not curvature, a lack of equality of spread a little bit more easily. Okay. Again, there's a couple unusual points. Let's ignore those ones and flatten it out. You tell me, does it look as though there's more variability for square footage higher than for square footage lower? I would say maybe. Maybe there's more variability for the square footage higher homes, the smaller square footage homes. There you go. Okay. Maybe a lack of equality of spread here. Let's try one more of these. And again, maybe start over and put along the x-axis the size of the lot on which the home sat. Lot size here. And along the x-axis, I'm going to go with the residuals themselves. Okay, I'm going to drag the residuals too. Okay, what is going on? Okay, I am not seeing that. Start over. Let's put residuals along the y-axis and then the lot size along the x-axis. Okay, again, wiggly, hard to really tell. Smooth it out a little bit. I'm seeing that's pretty flat. And for lot sizes that are unusually large, it's really hard to tell what's going on. So what I'm really only caring about is in the range where I see lot sizes, maybe up to 15,000 square feet or down to 5,000 square feet. In that range here of X, that very narrow range of X, it seems as though we don't really have a lack of linearity. What about that equality of spread? Again, you could, instead of your residuals, put the absolute value of the residuals there when plotted against the lot size, and that's over here. Hard to work with unless we make it smoother. Oh, maybe it's a couple unusually high residuals, whether that's dramatically overpriced or underpriced. Again, this is the absolute value of the residual. But these larger lots, it's a lot harder to predict, it seems, with precision than for the smaller lot sizes. Now, if we were to eliminate these data points here from my analysis, notice that I highlighted them. We can go down, find those that I highlighted. If we were to hide and exclude those from our graph, does it look as though it's much less steeply sloped? I would say maybe there's a bit of a lack of equality spread, but it's not dramatic just yet. Okay, so, okay, darn it, I hid and excluded things. And, well, I'm going to continue as though those hidden and excluded things just don't matter. Okay, so those are a couple of things we need to look for. Linearity, equality spread. Oh, yeah, normality. Normality of those residuals themselves are what we need. And if I were to show you that, you would say, well, I don't like the vertical scaling. Does that look normal? Maybe a normal quantile plot would allow you to say, well, with the exception of these few over here and these few down here that stretch things out a little bit, that looks pretty darn close to normal. You could also use a Shapiro-Wilk to check for normality. Okay. Here's the big picture thing, though. What if I showed you a graph of, again, the residual along the y-axis, residual sales price, and I'm going to go ahead and put the square footage of the home along the x-axis and ignore the wiggly bits, make it a little bit smoother. But if I were to show you in different colors, the different neighborhoods, neighborhood 1 in blue, 3, 4, 5, and 6, it seems though maybe there's a difference in the square foot relationship with residual in some of the neighborhoods versus the others. That seems to be quite clear here that neighborhood, these are the red and the orange ones, 3 and 6, neighborhoods 3 and 6, it looks as though the larger the home is, the more likely the residual is to be negative. Negative residuals correspond to data points below the trend line. In zones 3 and 6, we are over predicting the price of the large homes and under predicting the price of the small homes. On the other hand, in the blue and purple groups, at least, we see the other sort of tendency. The blues are always above average, and the purples are above average for at least homes above 1,500 square feet. But certainly, the larger the home is, the more the residual tends to be positive. In other words, under predicting the price of the home. Here, I'm saying I see a need for different groups because we have these different trend lines drawn in. And if the residuals could be predicted, and it looks as though I can predict them pretty nicely, from which group it is, which zone it is, I probably need zone included in my analysis. Similarly, if I've got different slopes for the square footage relationship with price in the different neighborhoods or different zones, I would see different slopes here in my residual graph. So I'm going to need to fit in those two additional terms. Okay, so looking at the residuals identifies something that I earlier just told you, oh, just do this. I'm saying in the residuals that we fit so far, you'd say the size of the house and so the square footage of the house, and well, the zone needs to be entered in, and zone's interaction with the square footage of the house also needs to be added in. If I were to run that model, you'd say, oh, you're happy as a clam. You've done this recently, and you know it fits better because of the interaction and the inclusion of zone. But now we get to start all over again with looking at things like linearity and normality and equality of spread. And again, what you could do is check for, well, I'm going to save those new residuals. And I'm going to check for normality first this time. So analyze the distribution of these new residuals, residual sales price 2 from my more recent model. And yes, it just gave it a name like 2, a little frustrating. Is that normal? I'm saying my normal quantile plot says no. That looks very bent at this upper end. Okay, almost sinusoidal in shape. I would say I'm not going to believe normality. So I don't believe normality. What do I do? Well, let's consider an additional couple graphs. And again, analyzer is maybe your way to no. Let's go with a scatter plot matrix. I don't know if I've had you do the scatter plot matrix just yet, but in the scatter plot matrix, let's have residuals shown. And I'm going to put my different X variables on the same graph. Sales price. No, not sales price, darn it. The size of the lot on which the house sits, the size of the home itself, so square footage. We have the year that the home was built, and I also put the number of bedrooms in the model for some reason. If I were to look at these graphs here, and now it's showing me wow, it's showing me the residual sales price is shown here. And do we see a graph where year built shows curvature? Maybe a lack of equality of spread for year built that's recent versus then. What about here with the number of bedrooms? This is a good graph, maybe a little bit problematic, but let's focus on this number of bedrooms because that seems to be an intriguing feature. 0 bedrooms in a home, well, that's odd. 1 bedroom in a home, there's only one home that looks like that, but 2, 3, and 4 bedrooms happen with regularity. Is there a lack of equality of spread here? How would I check for that? Well, I've got my residuals. And remember, if we were to use ANOVA, if I use fit y by x, and my new quantitative variable is the residual, and I have the number of bedrooms as a nominal variable, I could assess with this equality of spread, or the unequal variances method, unequal variances test. Levine says there is a noticeable lack of equality of spread between at least one of my bedroom groups versus the others. It looks as though there's less variability for some situations than for others here. 5-bedroom homes seem to have a lot more variability than the other situations. Okay. Is there a way we can fix or solve some of these problems? The lack of normality, the lack of equality of spread? The lab walks you through one part. The lab, the very last page says, if you have a lack of normality and you have a lack of equality of spread and you see a certain trend in the scatter plot of residuals, then we recommend a certain sort of fix by transforming one of your x's or perhaps one of the, perhaps your y, okay? And you should be able to, with the use of that chart on the back of the lab today, you should be able to sort of tackle any real life problem to the point where you say, either I fixed it or I'm sure I can't, and you would want to go ahead and call a statistician. One other thing is sort of interesting about this analysis that I had just done. And let's look at the interesting negative slope of the number of beds. For each extra bedroom that you have, you lose $4,300 in value. Does that make sense? By the way, maybe it's not statistically significant, but would even a negative slope make sense? Mulling it over for a second. Let's try it carefully. For 2 homes with the same lot size, the same square footage, the same year built in the same zone, would having an extra bedroom increase the value of the house or decrease the value of the house? Some of you know what it's like to sort of get rent or rent a place around here. Do some landlords take what was called a dining room and then put up an extra wall to sort of wall it off from everything else and call it a bedroom? Could you increase the number of bedrooms without changing the size of the home at all in square footage? Yeah. Does that really increase the sales price or the value of those sort of homes? It may increase the value to a landlord, but it doesn't make it as valuable for sale to someone who isn't intending to rent it. So it would decrease the sales price, and that's sort of what we're spotting here. Okay. One thing that we should be able to tackle through the lab is if you spot a clear curvature in one of the XY relationships, or better yet, the relationship between the residuals and then one of the X's, you might be able to, by taking a square root or a log or squaring either one of the X's or the Y variable, straighten out those sorts of scatter plots. You really need that linear assumption to be valid to use these methods that we're focusing on this week. Okay. I think that's it for what I wanted to be sure to share with you today. A little bit of what I did was review of a few key factoids from regression that you're going to want, multiple regression that you're going to want to review before the exam. Also, I set you up in some ways for the lab today which basically steps you through start to finish a lab which tackles the problem of whether the size of an acorn is related to the size of the home range of a species of oak. Biologically, you might be thinking, oh, little tiny acorns, maybe they could be picked up by a bird and travel further before they're deposited somewhere else and then they would grow, or maybe a pig would eat it and then sort of travel somewhere else and deposit it via a natural process in a new location. So, you know, the different size acorns may be differently likely to travel to a new place that species had been seen as much before. Even if it's only 100 yards at a time, over many decades or centuries, a species of tree could travel quite far and change its home range dramatically. So we've got oak trees in the entire US and divide them into the groups, the Californian and then the rest of the nation. And then you get to determine whether that is a valid relationship, yes or no, after the lab walks you through looking for some residual analyses, spotting problems, and fixing them. Okay, any questions before I turn you loose to do the lab? Okay, I'm going to say one thing then to close it off. And that is this week, it seemed as though earlier the week through yesterday, we dealt with the more challenging conceptual concepts that we're going to have to deal with for the exam. It's sort of done intentionally to put the chapter 8 and 9 stuff, which is pretty easy, especially because we've done it again and again and again this term. The formal presentation and then the homework exercises shouldn't be so bad. And so chapters 8 and 9 on the exam, but the last covered before the test was definitely intentional. And with that in mind, I think you're well suited to pick up with the lab and then studying and be ready for tomorrow when we're going to have those sample exam questions, and then you'll take the test. Last call for questions before I call it a day.
Does the sample exam cover partial F test at all?
Can you say that one more time?
The sample exam?
I don't remember. I think the answers to the sample exam are there, Anthony. And did it look as though I fit a partial F?
I'll take a look.
Yeah. So I'm saying if partial F was used, A, I would love you to recognize why that was necessary to use. And B, I'd love you to say, can I just do it myself? If I was given the right information, can I go ahead and tackle the problem? Or if there wasn't a partial F test needed to tackle problems on the sample exam, well, how do I know that we didn't need it? I mean, putting yourself in the position of a student who's taken the test, how do you know from each problem where you might feel tempted to do a hypothesis test with the partial F, how do you know you didn't need it and could have used either another method or that the partial F would have been an inappropriate method? Good question. I do want to mention one thing about those sample exams. Those were both from terms where not every student had a computer in front of them, like right around 2010 or so was when those two exams were from. And so we did not have those exams in a computer lab where students could actually use software to tackle the analysis problems. And so they were not intended for students to necessarily have to use the software. Read from the questions, the nature of the sorts of problems I would want you to be able to solve, but know that you will have access to the software as well. So that might speed up your calculations for some of the problems. But for others, you might think, oh, well, I don't even want to bother opening the data because I know I can do it by hand. Your test is going to be written about the same way, but any data set I use to produce your exam, I'll make available to you for the test. Yeah, good question.
So what
Someone
you're
else?
saying,
Yeah, please.
sorry, what you're saying is you might not provide us with the analysis and we'll just have to go into software and do it ourselves.
Oh, fuck no. I'm sorry. That was rude. Shouldn't swear in class. Well, okay. Or on videotape for that matter. No, I will generate for you every single analysis that I would want to give to a student who I knew would not have access to the data. I'll present to you everything you need.
Okay.
But if you know the software well enough to use it to speed up your work, great, use it. If you know how to use the software to come up with a hypothetical, like I suggested before the first exam, remember with the hand washing problem? I said, well, what if you had 32 data points? One student in a past class, at least with this question, it wasn't the hand washing, but it was a different data set. Try doing a cut and paste of the data points and then paste them downstairs and paste and yet again paste, quadrupling the data set size. And they found indeed the F ratio increased and they found mean square error stayed the same, but MST went up. And so, yes, what you sort of can do with the software isn't just analyze static fixed data sets. You also, with the software, can tackle these hypothetical problems by creating data that match or modifying the data sets you are provided to match the context of the problem and try something out, see what you get. If you're not sure how to do it by paper, put it on hold for a little bit, come back to it. If you're not sure yet again, and say, hey, is there anything the software could help me with? And the answer is sometimes, yeah. Someone else on a sounds sort of administrative in nature, Anthony. Okay, last call. Okay, so what I'm going to do is stop the recording now and boom, boom.